And finish lesson 20 finally. There will now be 3 different videos for lesson 20. What a long lesson, yeah. It's a long lesson. We've done a lot of stuff. It's very complicated. Graphing these things, there's a lot to it, right? We've had to use properties of logarithms, properties of exponents, all kinds of different stuff. There's a lot involved. And we're still going to continue on using properties of exponents here. So when we last left off, we were talking about this, what happened with this, right? We said that this was equal to 3 squared. Why are you guys trying to depress us?
That's what I'm saying.
Why are you?
I didn't know how many times you got. That's why.
All right, so we looked at that and we said that this was going to be a horizontal scaling. That it was going to look like a squeeze, right?
Yeah.
All right, so let's go ahead and that's what we did it. So that's actually the answer to that. Let's go ahead and graph f of x and g of x. So we're going to graph 3 to the x power and 3 to the 2x plus 1 power minus 2 on the next page. So I'm going to go ahead and write that. So we're going to graph f of x equals 3 to the x, and we're going to graph g of x equal to 3 to the 2x plus 1 minus 2. Is that correct? Okay. Okay, let's go ahead and graph this thing. So, again, we're going to graph the 2. I'm going to make a table x, f of x, and g of x. Let's look at negative 2, negative 1, 0, 1, and 2. Those are always nice. They fit in my scale usually, right? So when x is negative 2, f of x is 3 to the negative 2 power, or 1/9. Okay. Let's go ahead and graph that. If that's weird for you, you can get out your handy-dandy graphing calculator and graph it using that, which is probably not a bad idea. All right, now that I have my table of values, I'll just go ahead and look at what it looks like, and that way I'll be able to make sure my graph is as accurate as possible. So there it is. When I plot these points, it should look like that. So I'm going to go ahead and do it. So at negative 2, I'm at 1/9, which is real small. Really close to the x-axis, I should say. At negative 1, I'm at 1/3, so maybe a little more. At 0, I'm at 1. At 1, I'm at 3, and at 2, I'm at 9, and then it's going to go, the next one's going to be up at 27, right? So, something like that. Okay. What happens when I plug all those numbers in there for g of x? Well, if I plug negative 2 in there, negative 2 times 2 is negative 4. negative 4 plus 1. So let's actually go ahead and do that. So I'm looking at g of negative 2. G of negative 2. 2 times negative 2 plus 1 minus 2. You could just put that in your calculator, right? And it will spit out an answer for you. That becomes 3 to the third power, or negative third, right? Minus 2. And it might help to actually do that, right? This is 1/3, or sorry, 1/27 minus 2. It's going to be very small again, right? So, and let's go ahead. All right, 3 to the negative third power is 1 over 3 to the third, which is 1 over 27. I mean, you could make it, you could call that negative 2, you could get a common denominator and actually subtract them. But let's look at it as decimal for graphing purposes. There's no need for me to do all that work. So let's go ahead and just put this in my calculator. So I'll go to my calculator, and it was 2 to the 2 times negative 2 plus 1 minus 2. So I can just put that in, right? And it'll spit it out. It's negative 1.875. So we can put that in our table here. Negative 1.875. And then the cool thing about doing that with your calculator is that I can put the same entry in, and now I can change that to a negative 1. Here we go. So I can go up here, hit enter, and all I got to do is go over here and change that to a 1, hit enter, and I get the next one. It's negative 1.5. So I'll put that one in there. Negative 1.5. When I put 0 in there, that's easier, right? 2 times 0 is 0, plus 1, so it's 3 to the first power minus 2, which is 1. Oh, that's interesting, right? When I plug 1 in there, I have 3 to the third power minus 2, right? And you can just keep putting in these in your calculator if you're not getting the mental math that quickly. That's 27 minus 2, or 25. That's already off of our Oh, it's because where did I put? Which thing did I put this?
I think you put 2 different
Oh, did I in my calculator?
Yeah.
Ooh, shoot. Okay, we're gonna have to change that. Thank you. Oh, brother. Thanks. Oh my goodness. It's supposed to be a 2. I mean, yeah. Negative 1.963. Gotta change that. So these are incorrect.
All of them?
Just those 2.
Yeah, you just off a little bit there.
For our graph, it wouldn't have hurt bad, but
It really hurt that bad, because like
3, yeah.
0.8.
Yeah, because of the scaling, right?
Yeah. 1.8 and then 1.9. So
And then what did you get? What the negative 1 is supposed to be? Anybody? I'll do it. All right, negative 1.667. And then I think we're good. If I put 2 in there, that's going to be way off, right? So this is going to be big. We're not even going to put it in there. All right. At -2, I am at almost -2 for my y. At -1, I'm at almost 1.5. At 0, I'm at 1, so they share this point. And then at 1, I'm already up here at 25, somewhere up here probably, right? So it looks like y can't be -2, right? Do you see this happening? It looks like for very extreme values of x, right, our y value gets really close to -2. And that's a good thing to write. See that happening? As our x values get more negative, our y values get closer and closer and closer to -2.
Is that the situation, or that's just what we have
That's
here?
just for this particular situation. There is a mathematical explanation for it, but let's just look at the graph at this point, okay? Let's just say, hey, I see this number is getting close to -2. This number is really close to -2. I would imagine that if I plugged in -3, it would also get really close. And let's see, let's check it out. What happens when we plug in -3 in there? It should, if what I'm saying is right, it should get even closer to -2. Right? So we see this behavior, and that's how we're going to graph it. Okie dokie. Let's go ahead and do another thing. All right, based on what we know, we kind of don't have to go through graphing these now, right? We have talked about what each one of these things does in terms of a transformation. So you should be able to, at this point in time, know what's going to happen. What did the 2 do in the front of the logarithm when we were doing this? Right, that was a vertical scaling. It was a stretch. Right, we've looked at the graphs now, and if you don't remember, just use the method that we talked about before and graph each one of those changes separately. Okay. How about that -1? What is that going to do to the graph?
That could be horizontal.
Yes. It's going to be a horizontal translation. But it's going to go +1, right? It's going to go to the right one. Okay, with g of x, that 100 times x, I am going to have to write that as log base 10 of 100 plus log base 10 of x, right? That's going to tell me more about what's happening. What is log base 10 of 100? 2. What does this thing do? It's a vertical translation. It's going a vertical translation of positive 2, right? It's going to go, which means it goes up 2.
So that's the same thing with the stretch.
No. With the translation, it's actually moving it, right? With the stretch, it stays in place. It seems like it's a dilation. You know what I mean? It's like in geometry what you do with a dilation.
Yeah.
It stretches in relation to one focal point. All right, what's happening here? We're going to use our properties of logarithms. And this is great. Because, remember, when we're going to use our properties of logarithms, this minus sign does throw a wrench in stuff. It changes it up quite a bit. This becomes log base 5 of 5 plus, since we're multiplying there, log base 5 of x plus 2. Those are parentheses. That's, yes. I have to distribute my negative sign. So that's going to be log base 5. Oh, sorry, my bad. Log base 5 is, log base 5 of 5 is 1, right? So that becomes negative 1. I've got to distribute this negative sign here as well, though, right? So that becomes minus log base 5 of x plus 2. All right.
You distribute the log anyway, the negative.
Yes, it has to be done. So let's look at it. I'll scroll up so people can see better. This is a vertical translation. Of negative 1. What does this do? When we put a negative in front of stuff, what happened? It reflects it, right? That's a reflection. It's going to be about the x-axis. And what does this do? It's a horizontal translation.
Minus. I did, don't worry.
Of negative 2, right? It's going to go to the left 2.
What's that reflection across the axis?
Let's look at it. You're having a question about that? And if you have a question about what it does, go ahead and just graph that parent function, right? So we want to look at what happens with the difference between log of x and what happens if we put a negative sign in front, right? Negative log of x. It reflects it. There it is. So if you're ever not sure, just graph that little piece, just like we've been doing. All right? Okay. All right, let's look at this. So what's going to happen with this negative sign? It's going to be a reflection. But we're not sure. How is it going to reflect it? If we're not sure, let's get out our calculator. Does it reflect it about the y-axis or the x-axis? I don't know. Let's see. Okay. Let's see what happens if we graph 3 to the x power, and then we graph negative 3 to the x power. What's going to happen? It's reflecting it about the x-axis. Okay? If that negative sign, oops, that is not what I want. If that negative sign were here, it would have reflected about the y. Okay? So if we put the negative sign in the front, it reflects it about the and this here is a horizontal translation. The negative one. Okay, I can't stress enough, okay? There's so much going on with these. I don't expect you to memorize it. Use that calculator. If you have it memorized, that's awesome. That's great. But I would really, really urge you to lean heavily on your graphing calculator and check. All right? Check what you think the transformations do by looking at each little transformation in your calculator. It's going to be the way to go.
So, if it's a negative log, it's a reflection across x-axis or
the x-axis.
So for this one, how it's negative 2 times the negative 2 is also a reflection across.
Yeah, but if you have log of negative x, it's going to be a reflection about the y. Yeah. And you can always check it. Always check it with your calculator. There's so much going on here. You should really, really lean heavily on your calculator. I really recommend you do. All right. That's it for that.